Good morning. Hi. Here we go again. It's a review of what's coming down the pipe. This virus is changing so quickly. It's mutating fast, and it's going into younger populations. We have discovered the happy hypoxics. We're now looking at how this thing gets into the brain, and that we've known it's been in the brain stem. We haven't quite seen the evidence until lately, where it's showing up in the cerebral spinal fluid. Excuse me. An encephalopathy, which is swelling of the brain, which is a result. So if you get a concussion, you get a swelling on the outside and it kind of goes down eventually. Well, it starts swelling on the inside because there's rupturing of capillaries. There's a lot of fine capillaries, and that blood chokes out cells, starves them, drowns them basically. And it just gets bigger and bigger and bigger because there's no place outside it can grow. So that's encephalopathy. It's that type of reaction. It's a swelling, basically. Edema, they also call it. So let's, these neurological issues, I keep reminding you that the brain is very oxygen greedy. Of all the oxygen we breathe in, if we breathe any, the little oxygen that the happy hypoxics breathe in, including young children who are video gaming hours into the night with a non-solar light source. Solar energy, free energy for the visual system. Non-solar energy, it burns oxygen. So they have the cones. Oh gosh, I don't want to be drawing rods and cones. But we have our iris. There's the pupil, iris. Here's our eyelids, whatever. And so the cornea is where all the cones are. These are cones. And outside of that, the cornea, basically, and that processes colors. We see color during the day. During at night, we can't see color unless we have a special type of light to help us. And these cones are zero, don't need oxygen. They don't need oxygen. It's all solar process, photosynthetic type. Whereas at night, the rods, the cones, everything else, the black and white are rods. And the rods are very oxygen greedy. So I did a full, thorough investigation of this, looking at sundowning syndrome. When the sun goes down, the rods fire up. As we lose that solar light, the rods fire up. So that's oxygen use going to the visual system, which depletes it from the rest of the brain. And the rest of the brain will take up to 35, 40, maybe more % of our oxygen supply, to the extent we give it oxygen. Through evolution, depending on how the environment stimulates us to need fuel for what? For foraging, for sensory, for olfactory, for processing of where to get it, what to get. Is it healthy? Is it safe? Is it friendly? Is it not friendly? What's our memory of that? Where are memories stored? In the cerebellum. Let's get a brain up here. Okay, there's our eyes. We'll come back to the eyes if we have to. I'm not a specialist on that, but I do know how oxygen plays into that. Let's make a bigger brain today. All right, so there is the frontal cortex, the frontal lobe, basically. This is the temporal lobe. This is where music and memory. The hippocampus is in here. I think the amygdala is around here. This is the fear center. It'll put a chokehold on your whole brain very easily. Very strong system, but we don't need it. That's the point now. That's how that's a turning point in understanding how we can evolve within our own lifespan. When we activate this, there is cutting and cleaving and pruning, what they call it. Now you prune a plant, Well, to the degree that you hold your breath and are afraid and worrying and not helping others, when you help others, the whole network shifts away from the amygdala. It's that portal, I'm afraid, me, locks you down, and pruning. And what happens when you prune a plant too much? Not much left. So, so this is a low oxygen arena, this amygdala. It's involved in post-traumatic stress disorder. It's involved in other things like schizophrenia, epilepsy, allostatic load, all the risk factors in most disease models. Nobel Prize 2019, Greg Semenza et al., all the disease models. Hypoxia, this is hypoxia, low, hyper, under, hypodermic, under, hypoxia. Well, the rest of the brain is prooxic. It needs oxygen to thrive. Prooxia. This is a new word, a new term, or ultroxia. Ultroxia, that means that all that matters. You're like, I have experienced this. I have learned the science. I believe it. I am on an oxygenated brain. And the sensory is going, and the vestibular is going, and the mathematical is going, and the creative's going, and the instinctual things are going, and the helping others, getting out of that amygdala. Ultroxia. And you have to build towards that. Okay? So this is the ultroxics, prooxics, people who exercise and get out there and, stay healthy, oxygenated, work those lungs, get that vascular going to the brain through cardiovascular, dilates, opens the blood vessels so that all the oxygen can go to the brain. People have good, healthy family units, supportive siblings, if you're lucky enough, good parents, to the degree that parents know how to parent. Quality of life, socioeconomic standards, the ability to sleep a full night, sleep is a repair center time. Everything goes into the shop. Just like a car shop, it's not the best place to hang out, but it's necessary so that we can drive out in the country and enjoy a good ride, right? So oxygen gives you that good ride, and sleep is the repair shop. And when you are going on rocky roads, or I do have a PhD in communication, so I've got to make up these stories every once in a while. And, you end up in a ditch, man, you got to do that. It's a lot of work, wear and tear on the car, wear and tear on you, wear and tear on the networks. And the pruning happens again. So, all right, so we want to stay prooxic, or better yet, ultroxic. That's for our rival. That's the top of our Maslow's pyramid. Self-actualization and to infinity and beyond, and beyond. And this pandemic and quarantine has given us a wonderful opportunity to make choices that keep us oxygenated and open-minded to the possibility of learning the science that we have evolved in an oxygenated world. Okay, we'll come back to prooxia. I'm doing a series on that. Here's our wonderful brain. This is our frontal lobe, temporal lobe, parietal, and the occipital, where our visual is. We have a premotor area. We've talked about that earlier. It's called a medial, like in between the medial prefrontal, MPFC. There's little symbols for that. It's easy enough to learn. It's not real complicated. This is our area of speech on the left side. It's about that big too. This is the left brain over here. Blah 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 blah. If this gets damaged, no speaking. It's it's like there's only one way to get to the speech. if we're doing is talking. Now, if we're singing, la, 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 oh, Danny boy, pardon me, boys, is that the Chattanooga choo-choo? That one often gets people with dementia singing who don't speak at all, or people who don't speak at all. They are old enough to have early memories of that train. Chun, 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 like a train goes. And imagine, first time you hear a train, wow, that rhythm and that force and the vibration and the environmental resonance builds a very deep, strong memory. And always, almost by guarantee, you've got an Alzheimer's or dementia patient who doesn't speak at all. This area has been damaged. 70% of strokes happen in this area. That's all we do is talk. We need to understand there's a lot more to the brain than talking. Talking is kind of an artifact, like the bow and arrow. But we need more than a bow and arrow to do well. However you want to, make the analogy. So you leave the tunt about 3:45. That puts a clock into it, right? That's another memory. Every time they jump in. Almost every time their lips start to move when you say about 3:45. Dinner in the diner, than to have a ham and Carolina. Ham and cheese Carolina. So you're going the motor, wow, look at that train. There's the clock. I'm really familiar with the clock, and 3:45, that's how we used to say it. 3:45. In Baltimore, we know where, that's a cool name, Baltimore. Dinner, food is a very strong memory. Ham and eggs. That was a big meal back then in Carolina. Carolina is a great state. So those words, everything, that whole string of cognition gets them talking again. So it works around the one-way system and gets them talking other ways. That's what I do in Music is Medicine. So this is where, and that would be in the cerebellum. The cerebellum and the hippocampus where the memories are. Memory, cerebellum, I call it CB, where 40% of the brain cells are. Irregular verbs, I thought, I went, whatever. Irregular verbs, irregular. Lashley's rabbit studies, I think, made that very clear that irregular verbs are down here. And so if someone has a problem with irregular verbs and can't get irregular verbs, they probably have a problem in the cerebellum. So that's how we isn't this fun? I hope you're having fun, because I'm having fun. Okay, let's have more fun. Let's keep going here. All right, so there's this a premotor strip. It's actually kind of in a triangle. It's in this medial prefrontal cortex. I need a bigger brain or bigger board, one or the other. Then we have what we call the, I don't want it to be confused with what we have here, which is the motor strip. So when we think about something, I'm going to go do that. Yeah. Plan the motor. And that there's an executive here. Yeah, let's do that. And then you plan it. And then you kind of go through the motions. This is the premotor. And then once you do the motions, here's the motor. Motor. Sorry. And then and we've talked about the cerebellum motor loop, right? So you say, I'm going to do something. You send it to the motor to do it. At the same time, it sends it to the memory center in the cerebellum to learn how to do it. You're planting a seed here. You're saying, I'm going to do this. You go down the brainstem and you do it. Whatever you do, throw a ball. Beep. And then how you throw it, if you strain your wrist, or over pull on that muscle, or overextend on your elbow, or try to throw too hard the first time, If it's not easy, wherever you have the problem, when you make the throw and control it, that sends exactly what you did. There's a pattern here. You have this, 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 and this, right? That's a pattern. That's a seed of how you did it. And it may have been like, you need to keep working on that. Or no, you don't have to come down on yourself for it, but you need to realize that this plants a seed. A seed has been planted in the cerebellum as to how you did this. Here is how you did it. You had a weird wrist. You had a funky tendon in your forearm, antebrachial. You had a over-kicked your elbow. And so the cerebellum signals that you got some real work to do on this elbow. Something's wrong with your elbow. And as a result, I mean, our actions are informing the brain as to what our DNA needs to do, how our DNA needs to repair itself. And if you don't have the oxygen to support the areas of the brain that have the, so here's the motor and the elbow, let's see, I think the elbow is up. Oh, I think it's down here. There's the elbow. Actually, the hand is, oh gosh, no, here's the face. This is the face here. And then it gets up into the hand. So this is the hand area. This is the kind of the elbow area. It's very, very specifically laid out. This is the forearm. So all of these areas need to be changed because you had problems there. The point is not to teach the cerebellum the problems. The point is we've seen the ball been thrown. All right, I got the ball, kaboom. That's the best I could do, cerebellum, but I'm relaxed. I have all the parts to do it. You don't need to fix the parts. You need to fix the snap. You need to, we're gonna build roots. This is the cerebellum loop, right? This is the cerebellum loop. Gosh. I need to get a new board. So pardon with me. So we make the decision to do it. We tell the motor thing, we're throwing a ball, baby. The ball gets thrown. This happens. Issues, problems. We try to control it. We try to throw it perfectly the first time. And of course, you're not gonna do that. You have to throw it relaxed and imperfectly and enjoy it. You need to enjoy it. Because right beside the motor, and proximity doesn't mean anything really, but right beside the motor is the sensory. Sensory is sensory. And like, whoa, it didn't make it in the hoop. But I sure enjoy the feeling of that. I want to do that again. And we realize, oh gosh, it didn't go quite far enough. Just some dumb observation. And that dumb observation is put back in the cerebellum. And so the cerebellum says, I'll fix that for you. And what the cerebellum does, it takes that information, didn't quite throw it far enough. Just a simple, but we enjoyed it. It also plants that we enjoyed it. Yay, we enjoyed it. It will also plant, oh my God, I'm a stupid idiot. I hate myself. I'm dumb. I'm incompetent. It will plant that, and that will grow. We don't want that. We don't need that. Don't need it. Don't need it. It's not a contest. You win by winning, and you win by planting whatever you do, enjoy it. But keep doing it because we want to be the best we can be. We want to evolve as much as we can. And when we're doing that and understanding that oxygen enables that, that COVID does not have a chance with us. That's the beauty of this science. And that's the lesson that COVID is teaching us, because it is moving in on the hypoxics of this planet. And hypoxia, when you say, I'm an idiot, I did this wrong, I'm stupid, you better believe you're not breathing. You get mad, and that's even worse. You're planting evil, as it were. You're planting, competitiveness and getting rid of the competition. All that's cheating, basically. Oh, please. I hope this makes sense. I really do. Okay, so we're still at the motor loop, right? So we decided we're going to do it. This is the premotor. Premotor, that's, we start with the executive, really. I don't even think that's in the loop. We just say, okay, I'm going to throw that ball. My friend and I go to the drive-in movie theater, and we bring badmintons. We just boing, 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 20, 30 minutes. No one else is out there playing. I'm like, okay, we got the drive-in 2 hours early. Let's play. Let's play cards. Let's throw the stupid football. We don't care if we mess up. But see, we have to engage. We have to engage with life. And 200-300 years ago, we had to engage with life. It's called survival. It rots our rock. Okay, so all these things build. You stay oxygenated. You enjoy it, whether you miss the ball or throw it over or hit it high. The next time, after a while, you're like boing, 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 boing. You don't give up, and it's not even giving up. It's you disengage. You disengage. You commit to doing it. Your executive says, I'm going to do it right the first time, or I'm out of here. What kind of process is that? So this is understanding that process. So we have the executive, which is the frontal lobe, the premotor, which is this premotor in the medial prefrontal cortex, PFC is what it's called. That's a very important area. We can talk about that in memories, because it recalls when you bring up a bad memory, you say, oh, well, new pair of glasses, maybe it wasn't that bad. Now I'm going to change. I'm not going to be that way anymore. And next time I see that person, I'll say, I'm sorry. And hopefully they'll, we can bury the hatchet, as it were. And so that is what's buried. New memory, new platform, new and that's what's buried. So the next time you bring it up, that's what you bring up. Same with this motor. So that's just a memory, regret, but when we're actually doing something or learning a new skill, we start with the executive. I'm going to learn how to figure skate. I was thinking about that yesterday. I've been wanting to do that for years. And we send that to the premotor, where we think about, what do we have to do that? Well, we have to, attract a good socks and, call and see if they're open and show up. That's kind of a commitment. And, basic planning. We could go into this, I lecture on this for hours. It's a fascinating world. And I'm so glad I can share it with you. Then it goes to this motor strip. Let's just do right. So we've got sensory nice, and we'll just do motor here. Motor. On both sides. And there are two arms. And then there's a sensory, right? So it starts in the premotor, and then it goes to the motor. Just saying this, all of this needs oxygen. This whole loop, they call it a loop, because the premotor takes oxygenated energy. That's why we fuel the directive. The motor takes energy, not all that much. It's kind of a twitch thing. It's really like, all right, and a lightning throw. Did I get it right? Maybe, maybe not. Overthrow, underthrow. We're kind of marginally involved, while what actually happened and how much the extent to which we enjoyed it and can
commit, all right, I'm going to keep at this, right? I've committed to this. We fuel the directive. We fuel the commitment. We fuel the initiative. And then a report of what happened goes back to the cerebellum area. And what does the cerebellum do? So we do the motor. We can make a general review of what happened. This is these issues, the wrist, the arm, over through the shoulder. And that goes to the cerebellum. That gets reported back to the cerebellum where 50% of the brain cells are that all need oxygen. So to the extent that what we don't breathe, we are not oxygenated in all those areas that enable these things to happen. And so we enjoy it, whatever we're doing, especially for outdoors. There's all sorts of growth happening around us. So the environment's constantly changing. We don't see it exactly, but our instincts realize it. We have a lot of primitive instincts. I'm so glad we're doing this today. There's a lot to talk about COVID, but this is the solution. This is no symptoms going to happen here. No symptoms. And you know what? I don't even need antibodies because that virus doesn't stand a chance against this oxygenated, functional system. Sleep well, lots of fluid, lots of oxygen, the right kind of food, committed, making the right choices to my health and helping others. This is evolution. This is how we have survived to date. And if we understand this, is the way I see it, as we can continue to evolve within the human lifespan. 100, 110, 100, whatever. Because when the telomeres in the neurons and the cells of the body go down, it's due to hypoxia too. It's due to toxins, smoking, whatever we're putting in our body, misuse, overuse, abuse, trying to micromanage. This micromanaging frontal lobe. This is new. This is new cortex. This is new cortex. CRTX. Get my acronyms going again. Okay, so we have the executive. We're going to do it. Premotor. Okay, let me go through we're making the phone calls, setting it up. We finally get there. We oxygenate every one of these. Actually, this is the executive needs the least oxygen because it's like the wild west. So I can go here, there, here, there, here, there, here, there. It like almost, it's so loosely packed in there. These other areas are very dense. Millions and millions of neurons just packed together each other, waiting for their oxygen. It's like, yeah, let's do it. But this is like, okay, we can do this, 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 or this. It's much easier to just sit down and do nothing. And just, and while your visual system sucks up all your oxygen. And this just dies off. We need to understand this. We need to look at the science. And so, okay, medial prefrontal, and then it goes to the motor. So executive to, let me get another color. Executive to the premotor where we plan it. The premotor to the motor where we actually do it. At the same time, it goes, what happens in the motor goes to the cerebellum. When we do the premotor, we also get a signal. So that's part of the loop. So this is like 1, 2, 3. We do it. Actually doing it happens down here. This is 4. And then it's, however, it just goes. And then this reports back to the premotor. That's the loop. This is the loop. We're going to do it. We plan to do it. Signal the motor. It does it. What happens when we do it goes back to the cerebellum. Reports. So the cerebellum gets a plan. Then it get plus report, plus the action itself. Action a report. And then it goes back to the premotor with recommendations, I guess. While it literally plants seeds in the brain. All right, this gets a little messy, but I hope if you follow the lecture, pause it if you have to, if you're really interested. Let's keep going. So what happens when the cerebellum, in an enriched environment that is oxygenated? I have a really nice study with a bunch of animals I'd like to do to study this. So we've got the human in the watching TV over here, non-set at night, right? And using the visual system and playing with their twitch hands, right? And letting this thing, whatever, use our frontal lobe and our visual system. That's all that's done in the brain. It's not very much. So the brain is using the visual system, which has a little track and then hits up in this area of the brain. And here's the motor strip. The hands are around here. And so it's, kind of, there's your pathway. It's like a three-lane town, three-street town. Whereas the athlete is out in the day. It's lots of sensory. The visual system is free energy. We're just taking it all in, and it's, all free. There's no energy expense, right? In the visual system. There's all sorts of motor up and down, right? And there's all sorts of sensory that goes with that. And the cerebellum motor loop, if we're breathing, lots of oxygen's going in. Looks like a fish. And the loop is just, here we're doing this and that and this and that, enjoying it, being blessed, talking to others, helping others, knowing what we're doing is going to help others. And the loop just goes and goes and goes. And it's all oxygenated. We're cooking for friends. We're making sure they're laughing and both, helping each other. Helping each other is a great way to practice this stuff. So what happens in the cells? In the brain, there's a net. Here's the cerebellum, and it has 50% of let's say 50% of the brain cells, right? It's got stuff, and it's all motor. It's all motor. If we didn't have the cerebellum, we'd be like, oh, or if we move it all. The cerebellum, it takes energy to, boom, throw something accurately. Energy and ease. It takes energy to do the action, and it takes energy to keep it all easy. It takes a lot of ease. As I play the piano, it's a lightning type. Choo, choo. Now I see a lot of kids come in and they want to play the piano and they do like this. They get frozen in the control of it. That burns energy. Doesn't take it, it just burns it. And it also plants that as the memory. And what does that do? That signals to the DNA, you got a lot to change here, buddy boy. We got to take weeks and years to change what this person's doing, because there's no way we're going to be able to do, they see somebody play real beautifully and fast, and they come and they're ready to do that, trying to force it, rush it. When in reality, that action happens. Boom. Did you see it? If you freeze frame it, there's the action. There it is. It just takes a heck of a lot of energy to hold it up and try to control it. You can feel it. That's not how you play. That's not how the piano plays itself. The piano plays itself by boop, 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 5. Thumb, 1, 2, a middle finger, ring finger, baby finger. Pa-pa-ta-pa, pa-pa-ta-pa. That's how it plays itself. Just a jolt. But what have we done? What have we done by committing to sitting at the piano long enough to take the time to let that happen? Most teachers just undo bad habits because people have tried to micromanage the process. So what happens is that let's say in the ultroxic, this is just, we're just committed to staying there. It's almost like a dumb choice. I'm just going to be at the piano. I'm committed to be here for half an hour, and I'm going to see what happens. No expectations, innocently. And so they do transcendental meditation too. It's very interesting. And you say, okay, well, I've got that music, and I'm going to do this scale today. And the way I teach it is that it's a flash and let go. Total. There's nothing there anymore. It's just the weight of the hand that stays on the key. Boom. We do it this way. Bump. Bump. Here's the first finger. Let's do the middle finger. Bump. 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 You got the ring finger and the pinky, right? Okay. So that's what it plants. The cerebellum says, oh, I just need a flash energy, a flash pulse. Let's build that network. All right, here's the hand. Let's say the hand's right here. The fingers are right here. The hand's got quite a bit of space on this motor strip. And so I'll just build 5 flash networks. And I'm gonna put a lightning, and it's lightning flash. Fast lightning flash surrounded by relaxo. And that's how you build it. You know what? And you oxygenate before you do that. Because it takes a fair amount of energy to make a flash movement and let it go. Flash, let it go. Now, if you imagine in nature and all those, because the dominant system of our biological selves is relaxation. That is called the parasympathetic. So we have a central nervous system, and in that are movements that are autonomic and that we can control to an extent. And, most of that is sympathetic, means that you're responsive, reactive. And so if a big tarantula, that's my big example, or something else, a lot of stuff happens when I do that, when I have that response. My neck gets stiff, my shoulders get stiff. My jaw just goes up. I freeze. It takes energy to freeze. Burns energy to freeze, and there's no oxygenation of it. You immediately go hypoxic. And in that hypoxia, you're confused. Subconsciously, you don't know what direction you're going to go in. You don't know how you're going to escape it. The brain kind of makes those reactions happen. And that's Darwinism. But most of us, most of the time, 90% of the time, 99% of the time in this environment, 99.9% of the time, there's nothing that's going to crawl out of here. Not that I've seen recently. There's not even a plant in this office. Parasympathetic, outside of the reactive. That is the dominant system. That's our homeostasis. Low heart rate, low blood pressure, our skin, our muscles are relaxed, we're talking softly, our jaws, loose, long neck, loose shoulders. Okay, so that is the parasympathetic, and that's the dominant system. So that's where we want to, when we're learning to play the piano, we know we want to play that key loud and sharp and good. We want to be good at it, right? We want to be good at throwing that ball. So we just have to commit to it, fuel it. All right, I've got the target, and you have to trust the visual system talks to the brain too. And boom, where did it go? We're just trying to innocently, and then the brain will make a lot of corrections for us. So, I'll stop there for today. I was going to talk more about COVID-19, but what we do know is that COVID-19 goes on these folks, is moving in with younger people, happy hypoxics. And they are those who have low oxygen levels. They don't even know it. A lot of them are playing video games. A lot of them there's obesity. And that's not oxygenating and exercising. That's like just glucose, glucose, glucose. Other issues in the COVID-19, the red blood cells that are supposed to be delivering our oxygen throughout the system, often have some glucose. We need a little bit of glucose to process the oxygen because it connects with pyruvate. But glucose on its own can produce like a little bit of fuel for us. And so we're finding that the people in the blood cells in COVID-19 are covered with glucose, covered with it. It's not right. It's not right. And that could be perhaps because maybe the glucose is attracted to the COVID-19 unit. That's possible, or that it is sucking so much of the oxygen from oxygen, moving in on this hypoxic biosystem, such that the glucose is not even being processed, and it's just building up. It's just building up and building up. So that remains. Just keep looking at it. Just keep observing from the reports, from the science, from the patient base, from following the mutations of this COVID-19. Science starts with observation, and where there is causation, all you find is evidence. And so I will repeat once again, we have evolved in a highly oxygenated planet as a result of lifestyle, socioeconomic status, education, quality of parenting, lack of interaction with the environment and natural. So highly oxygenated we have evolved. Industrialization and everything that comes with it has thrown us into a happy hypoxic. We think stuff is going to make us happy, and video games and such. And it has also reduced our oxygen supply to approaching nil. And this was what we had before oxygenation. So this is where we evolved. Industry has flipped this. There's the flip. And now we are deoxygenated. Our planet has been deoxygenated. And so the environment for sure has de-evolved. Our environment has de-evolved. We evolved in oxygen. We bonded with mitochondria and say like a fungal type cell equals biogenesis. I'm following this, but there we are. People, animals, we're the same on that phylogenetic tree. Equals biogenesis. And look at us humans. Wow, we've done so much. We're still evolving. We're still had the formation of being on all fours. We used to be on all fours. Had a tail too. We still have remains of that, right? Whatever we were. And we were breathing, our muscles were lined up like this. We stood up and they've lined up like this now because we're still evolving. If we stay oxygenated and continue to evolve, they'll probably even out a little bit, right? As we move up in outer space, this happens. Everything rises up. So there's a lot of science, a tremendous amount of science, and evidence to support what we're looking at. Notwithstanding the DNA God, which is always working. And once you achieve, optimize this, something else shows up that's like a real God, a providence, serendipity, coincidence, whatever. Okay, so we have de-evolved. We've evolved in oxygen. Industry has flipped it, big flip. We get the DNA God through oxygen, and then the God thing shows up. Now we're in an environment that is de-evolved. And as a result, we are diseased, all the hypoxic. 2019 Nobel Prize in Physiology, Greg Semenza et al. From Hopkins. All disease is hypoxic driven. Hypoxic, low oxygen drives all disease models, including cancer. Okay, so evolved, and look, we have a COVID-19 comes along, moves right in on that. We have mitochondria here that moved in on oxygenation and created us. We have COVID-19 that's moving in on low oxygen, plus low oxygen equals, a new normal. We are de-evolving, and we'll see the ramifications of that. And there's a lot of evidence to support that. And we have to be aware of that. And work with that with our choices to decide which direction we're going to end up on. I think we want to continue to evolve. Let's try that. Let's try that one. Okay, this has been a long one today. I was going to, really, just do another review of COVID and all the terrible things that are happening, but let's look at the solution. This quarantine, I love it. You know why? Because it has rebooted quarantine. Has rebooted this. This is a new normal that is oxygenated. We understand where the COVID is targeting. We're not going to be that. We understand that hypoxia is all disease, that we can treat heart disease, lung disease, cancer with an oxygenated system rather than running for a pill that sometimes causes more problems. Doctors know this. Hopkins is the first one to teach me this. Hopkins is the first one to say it. Go to the top tier and they'll tell you all about it. I'm so glad, I'm so proud of my master's degree from Johns Hopkins in health science. God bless Johns Hopkins and hospitals thing. So this quarantine has enabled us to reboot and look how this earth has bounced back. I've seen it. A lot of people are talking about it. Wow, the planet has really bounced back. It doesn't take long. Life finds a way. So does an oxygenated system. Just like life finds a way when we deindustrialize for 3-4 months, one breath after another, pro-oxic. And I'm going to do that. I'm going to do a 10-minute video right after this. Thank you so much. I think this is my 53rd session, and I did quite a few before that leading up to it. But I am a solution-based, formula-based, cognitive behavioral neuroscientist and professional musician. And I'm putting a program together for St. Patrick's Day, and it's going to be wonderful. I'm going to sing, play the piano, and play for other people, and we're going to have a puppy party, and Lutheran pastors, master grilled chef, and it's all community. It's all to spread joy and the solution, community. Eating good things. He grills all these vegetables, and puppies give us joy. and that wonderful energy that is contagious and, bubbles up inside of us too. And we're outside, oxygenating, helping others, celebrating freedom, patriotism, all the good stuff. Bless you all. Thank you for being with me today. Thank you so much.